Hi friends. The following video is a culmination of a couple streams I did where the goal was to add Aseprite native file support to the Excalibur Aseprite plugin. Aseprite is a super popular tool in the game dev community for building pixel art. And this is a long video, but if you keep it on in the background at the end, we will have an Aseprite native file parser. So you can check that out or download the code and move it into your own game engine. And as always, a really big thanks to my sponsors. They make this possible. Hello. Hi, friends. Hello, hello. Well, today we are going to update the Aseprite plugin for Excalibur. Currently, it can load stuff from Aseprite, but only if you export the JSON piece of it. So, looking at this right now, in Aseprite, if you make an animation, you can use the export and export that animation as JSON, which is cool. But what would be even cooler is if we could read the native binary format of the Aseprite file. And part of the thing that motivated this today is the game from scratch video about the importer for Unity for the low price of $20. But I think we can make one and parse the binary format. The folks at Aseprite publish a file spec for the file, and it's going to involve some binary parsing. So I think that'll be fun. And this is going to be one of those streams where we're learning together. I haven't really done any binary parsing, so this will be real fun. So that's the goal for today. I can show you what it looks like right now. Let's close out this download. So here's the example of an animation, and here's just a still frame out of there. We can pull up that code, perhaps here in the editor. This is kind of how it works right now. You point at that exported JSON, and then we can grab the animation by name from Aseprite. So the animation's name is loop in Aseprite. So we can grab that. We can grab stills out of there. So I'm going to grab a still sprite out of there and use it as well. So that's what we were seeing over here. So we take a look. So we get that loop animation out of there. I can show you what this looks like in Aseprite. So if we look at Aseprite here, this is a powerful, I probably should have said, it's a powerful pixel editing tool, very popular in the industry for doing pixel art. And really useful for producing animations. And you can see that we have this tag, which is our loop animation. You can also specify your frame properties. So if I go here, you can say 500 milliseconds per frame, and you can do per frame as well. You can also do multiple layers and stuff, kind of like standard Photoshop applies. But yeah, so that's kind of what it looks like. Let's go back to code and kind of walk through what I'm thinking. We might not get through all of it, but we'll get through a good portion of it. I've linked here the spec for the Aseprite file format, and I can just copy paste that into the chat here if you're curious. We also, I'm also thinking about using something called a DataView as a way of parsing the binary content. So we can go look at that real quick, what a DataView looks like. So a DataView is what it sounds like, is you take a array buffer of some binary data, and it can work with Endianness, which is nice because we're going to need to. The Aseprite file format is in little Endian format, I believe. Let's see if I can find where it's referenced. Let's look. Little, yeah. So we're in little Endian, which is my least favorite Endian. But data views let us work with that, so I'm thinking we'll use a data view to kind of work through this. So that's my initial first impression. We'll get the file as an array buffer. We can use like fetch to do that, so we can grab here's an example using fetch, grab the array buffer, then we'll do our logic instead of this logic. And then at the end, I'm thinking we'll use Canvas to construct the bitmap that is we need for the raw images for the animations. So we'll need to construct a bitmap. So before this, I went and got a Hex Editor Extension from Microsoft to take a look at the binary file format, because we're going to need to parse it, which is pretty slick. This is the binary file format. Let's get rid of this. Of that beetle that we saw earlier in Aseprite, that example. So it's not a very big file, but it's got all the information we need for that animation. So it's pretty cool. So looking at the spec, we can kind of make some sense of this file a little bit. So all binary files have a header. So we have 128 28 byte header. And there's some goo in here. Specifically, we have a file size, and then we have a magic number. So, that's going to be the first thing that we do when we parse, is take a look at that. So, like, ripping back over here, we can say, okay, well, I've got if we look at the spec here, we have a D word. What is a D word? If you look up here, it's a 32-bit. So that's 4 bytes. So we got 4 bytes of file size. So, and then we have a word, which is 16 bits, unsigned integer of a magic number. So if we rip back over here to the final file part, so we got a D word, which is our file size, and I have this checked to little Endian here. So you can see that we have a file size of 2,657, maybe. But we have a D word, so we have 4 bytes. So that's 32 bits. So 1, 2, 3, 4. That's our 4 bytes. And then we have that magic number, remember. So if we flip back over here, take a look at that magic number. I'm going to zoom in. We have that magic number here, A5E0. And this is in little Endian, so it's reversed. So we have A5E0. So that's our header. So this is little Endian, which is the least significant worst, and then followed by most significant. So there we are. So that's our mention number. So that's how we're going to start. So, and then we can start looking at what we got here. So we have frames, and that's a D word. So that's that's just a word. So that's 16. So we look here, and then we says, okay, we got 3. That makes sense. That's how many frames we have. So that tracks. We have, going back to the spec, we have width and height in pixels. So we can take a look at that. So we have 40 by 40, which in decimal is 64 pixels by 64 pixels. So we have our work cut out for us. So I think like a good first step is diving in and getting the file downloaded, and then perhaps parsing some of this basic information out of it, and building up a data structure. So I have a list of to-dos, that we can go through. So we might be able to get through some of this today. We'll see how far we get. And this I took from the documentation from Aseprite. This is how to read a sprite. You read the header, and then for each frame, and then, we just saw that the header has that information. For each frame, read the frame header, and then frames have chunks, which is the individual pieces of information. We'll read those out, and then we'll go ahead and extract that pixel information and produce some images, and produce something in Excalibur. I'm going to call this an artifact, not a loadable. So, all right, so let's go look at what we got right now. So right now, the API for Aseprite in Excalibur, the way that it works is that you define a Aseprite resource. So an Aseprite resource is this fellow right here. So what I want to do is I want the user to be able to pass like beetle.asprite right here. And then really, I want this API to stay the same if we can get it to do that. So what that'll mean is in the load, when we're loading, we're going to have to load and parse the binary format to produce a data structure that we can use in the same way. So that's the plan. So, okay, what do we need to do here? Well, right now, the constructor is expecting JSON. And in fact, there's a built-in resource that you can use in Excalibur that knows how to download things from a path. And it's expecting JSON. So I want to refactor this code. So let's see if, we can do it based on the extension for now, which is a good start. And we're going to download it as an array buffer, which is just as what it sounds like is, it's an array of bytes, basically. And then we can use a DataView to parse it out. So what I'm going to do is I'm going to just call it native resource for now. And we'll refactor this later. Path, and then we'll give it an array buffer, and then bust cache. It will pass through to bust any like URL caching. And we only want to do this if, let me actually define this here. And usually what I wind up doing here is this should be a array buffer. It's a resource of array buffer. So, so like in this example, we're just grabbing the raw JSON, and this is just the shape of that JSON. And then in this case, we're getting an array buffer out, and we just want an array buffer. So what I want to do is I only want to do one or the other. I don't want to do both. So ends with is not going to work properly, but we'll do it for now. The thing that I'm worried about is like if you have a query string, like this will fail. But for right now, we're going to start with an ends with. So if we got an Aseprite, we're going to do this. Otherwise, we're going to do this. I think what I'm going to do is, or null, or undefined, how about that? I think what I'm going to do here is I'm going to make a type, and it's going to be, this is just going to be like native or JSON, just so that we can switch on something. And we'll just do, well, maybe we'll do native by default. So native, oop, and this is JSON. Cool. So that way we can switch on some stuff here. We have some load logic that we'll have to refactor as well. And some logic here that we'll have to figure out as well. I think I want to also squirrel away the original path as well. And we'll grab that as well. We'll squirrel that away. Cool. So now we've got a native resource now, and I'm going to put a fix me in here. Ends with is problematic for paths that end with a query string or hash. So that'll cause problems, but we'll fix that in a second. So in our load, we want to switch on type. So if our type is JSON, we're going to do the same thing we did before. And we know that the resource is there, but I'm going to put a guard in here just so we don't have to check. Else, we're going to go ahead and do our other parsing. Type is Aseprite, or type is native. So we're going to grab the array buffer. So we should get an array buffer out of here. And what I think I'm going to do is we're going to return a, what does this need to be? I'm just going to return something broken. I'm just going to return null. Sure. Yeah, we're gonna just do something broken here because I want to set a breakpoint. Okay. So let's see what this looks like. I'm a big fan of making stuff work just enough. Let's we can actually fix this right now because we squirreled away the path. So we can fix this. Cool. So I think we don't have any build errors anymore. Let's see. So it looks like it's building. Let's go to our test here and change this to Aseprite. And let me double check that everything's working. Looks like it is. So let's see what comes out in the browser. Let's get a sources. Let's see. We should have some. Awesome. We do have some source maps. Okay, so let me set a couple breakpoints here, and then we'll reload this. Okay, so let's take a look here. I'm just gonna make this just totally as big as we need it. Okay, so we've got our path. We're gonna not bust cache. It's type native. Okay, so let's continue. I'm gonna go ahead and load. Cool, so we got our byte length here, 2657. That meets with my recollection of that header format, and then we're gonna shoot out a null. Okay, so that's pretty good. Now we need to parse it. So let's take a look at our bytes here and see what it looks like. Are we in little Endian? So it says 9710, and if I take a look at the file itself, so what was I looking at? I was looking at uint8 array. So this is interpreting them as integers. Unsigned int 8 array. Interesting, because this is, what is this? Because 61, go look over here. 61 is what in decimal? And in 8, it's 97. Okay, so it's interpreting each byte as a decimal value. That's fine. And then our next one, A is 10 in hexadecimal. So, okay, so everything is in little Endian. So the file looks like what I expect. Also, the file size is what I expect it to be. It's 2657. That, excuse me, that matches with what we're seeing here. Cool. Very slick. All right, so let's start parsing. So I want to look at using a DataView. So with a DataView, we can pass a array buffer to it, and then we can work with Endianness here, so we can like set and get values depending on Endianness. So yeah, that looks like what we want to do. Oh, and there's a get 64-bit integer values. That's interesting. Cool. Very nice. Okay. We might have to use that later. Let's see. What other things do we get on a data view? We can get at the byte length. Constructor seems pretty low key. Awesome. So let's just do that. Do that real quick. All right. So we're in our load. Array buffer. It doesn't like. Oh, because it could be undefined. So we got our data view. I want to get int32, which remember int32 is going to be our in this world a D word. So if we're going to look at the spec here, D word is 32-bit unsigned. So actually I can get int. I need to get uint32 unsigned int. So let's just start parsing the header here. So that first thing is file size, and that's right at 0. And and I think I'm seeing myself add wanting to add constants. So we'll probably do that as we go through here. So we have that first thing is file size. Then we have the magic number. Let's see, I'm gonna actually camel case these. So our magic number. So we're gonna get a word, which is just a uint16, and that is at after the file size, so that's at index 4, right? So I'm just gonna type it in here, dword add 0, then so dword is 4 bytes, 32 bits. And then we're going to get a word at 4. And then the next thing we're going to get is the number of frames. So that's const frames, DataView, get uint 16 again. And that is at a, what? That's 2? uint16? That's 2 bytes. So we're going to get that. So that's another word at 6, right? Not at 4. Oh, you know what? The other thing I forgot to do is this is little Endian. So we're grabbing these little Endian style. So we have to throw true in here to grab the values of that little Endian out of here. So let's stop there and make sure that we're doing okay here with this parsing. So let's stop here and make sure that it's actually returning what we expect over here in the browser. So let's go ahead and refresh this page. I don't need a breakpoint there. Okay, let's see if this lines up with what we see in the Aseprite. So our file size should be 200, and I've already forgotten. Should be 2,657, and our magic number should match the Aseprite magic number here. Again, that's little Endian. And then we should get 3 frames, and then we're 64 by 64 pixels. So let's see what we get. So we're going to load our array buffer. We get our data view. Remember, our data view is going to allow us to dig into this array buffer, and regardless of Endianness. And that's just built in the browser. So our file size here, 2,657. All right, so far so good. Our magic number, no idea if that's right. Let's see. That's our magic number is I'm going to go over to our hex editor here. Is A5E0 according to the spec. And this is, again, little Endian, so it's in reverse order. But that seems to match with the number that we got, 42464. Yeah, that's what we got over here in the browser, 42464. That's our magic number. And that's just, you know, something you put in these things just to see, like, if it's the right file or not. Okay, and then so for frames, we should get 3. Except I stepped over it. Cool. Let's see if I can fix that so we don't step over it. Let's do that real quick and refresh this. Okay, frames are 3. Sweet. Awesome. So what I'm going to do is I'm just going to squirrel away what this magic number is and make sure that we're checking against that later as like a validation step. I'm not going to do it now, but all right. I'm just going to grab the A5E0. Cool. Neat. So let's see what else we have here in our spec to parse. We're going to get at color depth, which will be important because you can have in Aseprite, you can do like RGBA, which is what I use most often, but you can also do grayscale, or you can do something called indexed, and that's when you index into a specific palette, and we want to support all of those. So we're going to need to grab that information. So what I'm kind of thinking here, as we're working down the file, we almost need to keep track of our current position, and then add as we were accessing to kind of like to advance a cursor. So like that almost would make too much sense. So let's see. Let me get this. Get the pixels here real quick, which are UN16. So that's another 2 bytes, which would be 8. Little Endian, and then 2 bytes is 10. Height. So okay, so let's do this. I'm gonna make a cursor, which starts at 0, and then I'm gonna maybe what I want to do here is I want to make a helper. Okay, so let's make a helper here real quick. I'm going to create a class here called Aseprite native parser. Aseprite native parser. I'm just going to make it parse a array buffer. And I'm just going to grab all of this stuff that we've done. Yoink. Might even, yeah, I'll just leave it like this for now. And then what I want is I want to have a cursor. And what I'm going to do is have a helper that will read and advance. So read and advance. I'll just call it read D word for now. And it will return a number out. So what it'll do is it's going to grab, it's going to read out of the data view. And I'm going to make this actually, we're going to pass the array buffer right into the constructor here, so that I can also create the data view. That way we can just rip through this and not have to keep track of the arithmetic ourselves. So we can just read a D word, and when we're reading that, it'll do the right thing and then just throw out the right number. So that's a D word, and we're going to read a word, and that's 2 bytes. And I need to return the value out of this. Cool. And then I'm going to make sure that I get all the other types that are listed here. I see the next one that I see is byte. So let's make a read byte. That'll just be 1. We'll get a byte. And Endianness doesn't matter when you're reading a byte. Cool. All right, so let's refactor this real quick. So, so our file size, we're going to read a D word. Magic number, we're going to read just a word. Read a word. Read a word. Cool. So we've got our width and height, we've got our number of frames. Let's see what else we gotta read here. So we gotta read the color depth. So this is gonna be a type. So const color depth. So this is gonna be another word, and then we're gonna need to have a specific type. So we're gonna read color depth. So if let's see, if it's bits per pixel, so it's 32, 16, or 8. So bits per pixel, const color depth is going to be one of three values is going to be RGBA, grayscale, or index. So if color depth per pixel is 32, we're just going to go with this RGBA. Well, and we'll squirrel these into a type later, but I just want to get it parsed out here as we go. There we go. So there's our color depth. So if it's this, it's RGBA. Else if color depth bits per pixel is 16, then it's grayscale. Else if color depth is 8, then it's indexed. Cool. All right, so let's look at what's next. We have a bunch of flags and stuff that I might not care about. So that's might be the next refactoring that I want to do, is I might want to skip over stuff. But we'll get there in a second. So we have a flag here. The layer opacity has a valid value. So we're going to go ahead and read. Hey, good to see you, Chris. Yeah, the stream's going okay. I'm parsing a binary file, so it's gonna be fun. I don't really do this very often, or ever. So we'll see how it goes. There might be, you know, if anyone has a better way of doing this, I'm all ears. All right, so we're reading in the flags here, ripping through the spec here. So we want our speed. This is speed in milliseconds. We're going to read that as a word. This is deprecated, but we still need to read it to advance our cursor. Switching back to the code window here. And it looks like we have a couple of D words that we need to read. So I'm going to read D word. I'm going to read 2 of them in a row. Here. Empty reads per spec. I'm going to grab the spec file here and paste it right at the top of this. I'm sensing another refactoring coming, because we're just parsing the file header right now. So parsing the file header, we're just going down the list here. We need to read the next thing, which is something called palette entry index, which represents the transparent color. So I'm going to call it const transparent index. That's another byte. So we need to read a byte. This.read byte. And then we have 3 bytes that we need to ignore. So we'll ignore these bytes. You know what I'm gonna do? I'm gonna add a way to advance the cursor. I'll just say advance bytes. So we can just rip through some bytes here. So advanced bytes 3. Then we've got a word that we need to read. So it's the number of colors. Exciting stuff. Let's see, is there anything in here that we can skip over? Pixel width. Pixel ratio is defined as this and this. If pixel height is 0, then pixel ratio is 1 by 1 pixel height. Didn't we already get that over here? Height in pixels? Oh, this is the size of the pixel itself. Oh, I see. As an aspect ratio. Okay. So we'll read a byte. Say pixel width, pixel height. The next thing we need to get is the X position of the grid, and this is new. We're going to read a short. So let's figure out what a short is determined in this. A short is a signed integer value, so we need to read short. So let's do that real quick. So it's the same as read word, except except read word has a bug in it. It needs to be uint16. Read short. We're going to get int16, so it's not unsigned. Oop. So short is 16-bit signed integer. Word is 16-bit unsigned. That's what we got here. Okay, so rocking back to where we were in the spec here, we have the X position of the grid and the Y position of the grid. I have a feeling that we're not going to need some of these because these are like editor specific values. So I think a lot of these we're going to wind up, discarding. But I'm just going to rip through this one for now, and then we'll go through and figure out what we actually need. Read a short. Read another short. Let's see what we got next. We got to read the grid width. And this does feel like this is a editor specific, so I don't think we'll need some of these. But this will help us understand like what we need. Okay, and then there's 84 bytes of zeros, so we just need to All right, so I think that's all of the headers. So we should have read, according to this, we should have read 128 bytes of the header. So let's see how we did. Let's refresh this here. Oh, it didn't build. Oh. Cool. All right. Let's go back. Just had to adjust a return there. Okay. Still didn't build. Okay. Let's go like that. One more try. 2 more tries. Still not. updating. Well, oh, you know why? Because I'm not using this new parser. Okay, so let's go and use our parser now. Sprite native parser, array buffer, and then we're going to call parser.parse. And we're going to do this if the array buffer is not undefined. Oop. And just delete all this stuff. And parser wants an argument that I don't have anymore. Let's get rid of this. Cool. Save this. And let's see how it's doing in the browser and make sure that everything looks right. Okay. So, our file size, does that look right? That does not look right. Okay, so something has gone wrong right away. Our file size should be, if we're looking at here, should not be that big. Should be 206 or 2,657. So what has gone wrong? Read D word. All right. Let's see. So that makes me think I'm doing something wrong here. I thought we were doing it right earlier. What was I doing different here in the parsing? You went 32 at 0. Oh, you know what I'm doing? Okay, I know what I'm doing. So I'm rookie mistake. I incrementing the cursor before I read it. Okay, so let's do the thing that we should have done and grab the data out of here and then return it. That's the deal. All right, so let's fix that up. I just didn't want to write more code. Return data. Return data. Abundantly clear that that wasn't going to work. All right, so, you know, that's what we get for doing it live. Cool. All right. Well, let's check that out. Let's go over here. What I haven't saved. Oh, just my to-dos. Okay. So let's go check that out in the browser and see how that's looking. Refresh this guy. I don't need a breakpoint here anymore. All right, that's what I remember. And that's our magic number. And we have 3 frames. And we are 64 pixels by 64 pixels. And our color depth is 32. So far, so good. We have some flags, and that seems okay. Speed is 500. That is correct. We can, you know, we can verify some of this here by looking at the JSON here. You know, we have our speed 500, and we're 64 by 64 in our JSON. We're going to read some empty words. Transparent index is 0. What does that mean in the spec if it's 0? Only for index sprites, so it's just going to be 0. Number of colors, 32. Pixel width is 1 by 1. Position of the grid, 0, 0. Grid width, 16 by 16. Then we're going to advance 84 bytes. So that's the end of our header. So you know what I'm going to do is I'm going to refactor this real quick into a method that's just called parse header. And then we'll go into this next bit, which is the frames. So each frame has a little header of 16 bytes, which is actually pretty convenient because if we look at the Hex Editor, one row is 16 bytes. So if you were to do a quick glance here, let me zoom in. Oh, can't zoom in on the, nope, can't zoom in on the Hex Editor. All right. Or maybe I can if I do this. Nope. No, that doesn't look good. All right. Well, this first 8 rows, this is the 128 bytes. So, you know, here's our 84 bytes of zeros. Here's our header that we just parsed. This will be the first frame, and this is the first frame header. So that's what we'll do next. So let's do a really quick refactoring here, and we'll call it private parse header, just to kind of keep ourselves oriented about what we're doing. And I just want to get through here before we start exposing these values, and then we'll expose the values as we go. So there's our parse header, and now our parse is parse header. And we need to parse all of our frames. So our frames, a number of frames here that we have 3 frames, so we'll need to actually scroll that away. So we'll need to let's see, I'm just gonna call it number of frames. Or maybe I'll just call it frames. So we're going to iterate through for I less than number of frames, I plus plus, and then parse the frame. So then we need to scroll this away. So that's our number of headers. A little smaller. Yeah, there we go. All right, so now we need to parse the frame. All right, so each frame starts with the number of bytes in the frame, a magic number, a old field, frame duration in milliseconds, some empty bytes, and the number of chunks in this frame. And for each frame, we're going to parse all of the chunks. So going back to the to-do here, let's take a look at what we got here in the plan. So we've nailed this. We're working on this. We've nailed the header. So now for each frame, that's where we're at. We're at the for each frame. So we've nailed the header. So now we're working on the for each frame. So we'll work on that. We'll read the frame header and read the chunk data, and then we can extract all that data and make a thing. So that'll be cool. All right. Cool. All right, so we're going to parse a frame. So our current cursor should be at the current frame. So that is fine. I think we're going to need to make a method to jump the cursor around. But let's do that right after we parse this first frame. Okay, so first frame, we're going to have to read frame size. I have a feeling that we're going to have to return the frame size out to jump to the next frame as we're reading them. So we're going to read the D word There's the frame size. There's a magic number, which is just a word. And this is the old chunks. According to the spec, we'll read a word there. We have frame duration in milliseconds. That is another word. We have 2 empty bytes. So I'm just going to go read byte. Do that 2 times, not 3. And then we have the new frame chunks. New chunks, which is a D word. And if it's 0, we use the old chunks. Okay, so cool. So that should get us our first frame header. So that should be 16 bytes. And then we need to read each chunk. So what I might do is, let's see, we want to read, how do we want to do this? We want to read, do we want to read each chunk in here as we're running through the frame, and then we're just working down the file linearly? Maybe that's the best. That way we don't have to jump around, and that we can just work down the file linearly. I'm kind of into that. So let's do that. Let's read the chunk, all the chunks in the frame. Number num chunks is either, what's that, if new chunks is 0, use old. Otherwise we use new chunks. All right, so what we'll do is for let I equals 0, I less than num chunks, I plus plus, we're gonna parse the chunk. And we should probably call parse frame and then parse chunk. So private parse chunk. All right, so let's read about chunks. How much could a wood chunk if a wood chunk could chunk wood? All right. So chunks look like they store arbitrary byte data. The first chunk has, there's a chunk size, there's a chunk type, and then chunk data. And then the type is going to tell us how to interpret the data. So let's grab that. So we need the chunk size, which is a D word, const size equals this dot read D word, const type is just a word, and then we have some depending on the type, do other stuff. All right. Okay, so depending on the type, we're going to do something. Okay, so let's see what types we rip through here in the debugger. So what I want to do is just work on the types that I actually have in this current file, and then we'll have to go through and implement all of the other types as we go. All right, so we know we can parse the header. We know that we have 3 frames, which is good. We're going to parse the frame. So we got our frame size, which is the amount of data. We got our magic number. Let me compare that with the magic number that I know it should be. 61. Yep, that's the right magic number. That's good. So we got old chunks. We got frame duration, which is 500, which is we expected. Then we have new chunks, which is 6. So they both agree. So 6 and so it's just we have 6 chunks total. Cool. And frame size, this is in bytes, or must be in bytes. Yeah. Okay. Cool. Oh, you know what I should have done? I should have called Parse Chunk. So let's do that real quick. So we'll parse chunk. So, okay, so if the frame size is 1143, and that doesn't seem like it makes sense. All right, well, we'll work through that. Okay, so we're parsing the chunk. We get a type, and then we're gonna, depending on the type, we're gonna do something with it. So here's our type. Here's our types. So we have old palette, layer, cell extra, color profile, extra files, mask, path, tags, palette, user data, slice, tile set. Okay, so let's see which one has the pixels in it. I kind of want to look at that one first. Cell? Yep, okay. Cel Chunk has the pixels, so that's going to be the important one to figure out. So I'm going to grab the types here and just put them in the comments so that we know we need to handle them. So there's the Cel Chunk, and that's going to have our pixels. There's the layer chunk. I kind of want to work with the Cel Chunk first because that's going to be the one that's going to show us like anything visual. So old palette chunk, and oh, there's another old palette chunk. There's 2 old ones. Old palette chunk. Spelled palette wrong. All right, so let's see, what did I miss? 205 is Cel Chunk. That's where we have our pixels, and then there's extra cell. And then 207 color profile. 2007 is the color profile. And then external files is 8. And mask, which is deprecated. Chunk. There's a path that's not used. Tags, which is going to be the one that we want to use to figure out what type of animation we want to do in Excalibur. And then there's a palette chunk. There's going to be a few of these. This might take more than one stream. And then there's user data. I think that might be it. Is that all of them? Oh, there's slice and then tile set. Is that the last one? Please be the last one. Slice. Did I miss one?
Oh, I didn't miss one. And tile set. That's it. Cool. Okay, so I want to use the size to skip ahead. I basically want to say if type is the one that is the cell chunk that has the pixels in it, I want to skip to that because that I want to be able to get like the pixel data out of there and work with that real quick before we do anything else, because I feel like that's going to be a lot more interesting. That way we can get something to show up on the screen. So so if the type is Cel Chunk, I want to parse that. Else I want to skip by size. So I'm thinking the size is in bytes. Let's see, is that right? Let's look over here at the documentation real quick and see if that size is in bytes. Chunk size. Chunk size is a D word of size itself, and word is chunk type. Okay. I think that's just in bytes, so I can probably skip anything that is not I am not parsing. So we'll try that. So let's see, if I'm going to read a cell, it's going to have a layer index is the first thing. That's a word. And then there's a short for X position, Y position. And then we have an opacity level, which is a byte. And then we have cell type. And that's a word. We have Z index. Which is a short. I might redo these so that I don't have to type read short. I might just say word short byte. That might just be a little easier. Maybe a thing for later. Then we have to advance 5 bytes. So we'll do this dot advance bytes 5. There's 5 empty bytes. And then we have a cell type. So okay, so we need to switch on cell type. So if cell type is 0, we're dealing with raw image data. So that's the thing I care about. So then we can read the width in pixels. Height in pixels. And then we have an array of pixels, which is all of the pixels. So for let I equals 0, I less than width times height, we're going to grab all the pixels out of there. Okay, and let's look at the spec here for pixels. So there's a pixel. What does a pixel consist of? And I might need to make a data structure here for this. So they have a pixel. Okay, so a pixel is 4 bytes normally. Each pixel has 4 bytes. So there's RGBA. So there's 4 pixels for, or there's 4 bytes for red, 4 bytes for green, blue. Okay. Yeah, that makes sense. Each pixel has 4 bytes in order. Yeah, okay, that makes sense. Cool. So let's make a little helper here that's read pixel. And you know what I might do is I might shoot out an Excalibur color when we read a pixel. That way we can have color stuff. Yeah. Read pixel. So then we're going to go and grab the data. DataView. We're going to. Okay, so let's see. We got to read each pixel, have 4 bytes in this order. I'm assuming it's 4 bytes per color channel, or is it two? Okay, no, it's 2 bytes per color, because that would make sense, because that's 256. Yeah, so we need to get RGB. So we'll get red, which is get a UART16 here. G and B. So that's 2222. Okay, RGB. A. And that should get us our color. And I think color needs to be over 0. It needs to be between 0 and 1. So RGBA 0 to 255. And then this should be over 255. Cool. I think that will read the pixel. So let's do that real quick. Let's read our pixel. Read pixel. And then we get a pixel out. Pixels. Push. We'll just read them out and put them in the list. Sweet. So then we'll have pixel data. Let's see if that works. Let's go look at the browser. See how far we get. Okay, parsing header. We've already done that. We got our frames. We've done this already. I'm just going to jump out. Okay, so now we're going to parse our frame. We got our frame information. We know that we have 6 chunks to go through, so we're going to parse 1 chunk at a time. So we got our first chunk. It's 22 bytes. The type is, I'm not sure what type that is. We're going to advance 22. All right, so I think this is going to work. So let's make sure that we can get to the thing. Oh, we got an error. Out of bounds. Okay, so we did something wrong. Let's see, where are we going wrong? Let's see, let's do, can I break on exception here? What's going on? Pause on uncaught exception. Here we go. getting caught somewhere? All right. Well, let's see if we just step through it then. I'm going to set a breakpoint here on chunk. Okay. So size 22. Let's see if I advance the amount of bytes. Type 0. There is no type 0. What's going on? It makes me think that we're doing it wrong. Ooh, that doesn't bode well. That number looks real bad. Okay, so something has gone wrong. That is definitely the wrong size. Okay, so we're definitely not doing something right. Okay. Felt like the first two were right. There should be 6 chunks. What are we doing wrong? I am unsure. Well, let's figure out what this is in binary or in decimal. So that'll help us out. See if we're actually anywhere near. So 8197 is decimal. All right, so let's refresh here. I'm gonna redo our breakpoint here. So parse chunk. So size 22. Looks like we're in the right ballpark. So this first one is good. And let's see if I can find the size here in the Hex Editor real quick. And so we can see where we are. Okay, so we should be looking at this header for frame, and this should be our first chunk, which is 22, and size 22. And this type is, let's see, what is this type? So size is dword, and then we have this type, which is 2007. Okay, what is 2007 in our code? It's a color profile. All right, so if it's, this should be, so this should be 22 bytes. So the problem is either that I'm advancing the wrong number of bytes somehow to the next one, or something else. Okay, so let's look at the color profile here. Let's see what's going on. Maybe we parse color profile first, which is 2007. All right, so let's look at that. So we're gonna go ahead and parse 2007. So this should be type read word. This dot read word. fixed. Ooh, what does fixed mean? Interesting. Okay, so what is fixed? Fixed gamma. What? What is that? What is fixed? Fixed. Oh, it's fixed floating point. Oh, I see. Fixed floating point 16.16. So, okay. Is there a way for me to read fixed floating point? I don't know if there is. I might have to do some shenanigans to read fixed floating point. Well, we'll find out. Let's try to do that. So let's find where it was fixed. Okay. Let's go to code. All right. So let's take a look here. So we need to be able to read fixed floating point. Private read fixed is a number. So it's a 32-bit, so it's 16.16. So I'm assuming that's 16 in front and 16 behind the decimal place. Who knows? Can I read get float 32? Or should I do I don't think that'll be right. If I read float 32, that won't be right. I wonder if I need to do read uint 16 and uint, just read two uint 16s and then do a parse int on them or parse float on them. This is going to be a hack, but there's probably a better way to do this, but I think this is what they mean. That's 2 bytes. Ooh. 2 bytes. And then what we'll do is we'll do parse float. I don't know if this is right, but we'll give this a go. All right, so that should read a fixed. All right, so we're going back here. This is the gamma. Read fixed, and then we have to read 8 bytes. This time advanced bytes 8. And then if type is ICC, use the embedded ICC profile. So if type equals 2, there's the ICC length, read dword, and then there's a bunch of bytes, ICC profile data. Step read bytes. We need to be able to read a byte array out. So for now, what I'm going to do is just advance the bytes. I don't know if that's right. Okay, let's see if we get any further in the parsing of the binary data. So, all right, so let's see if we get any further in the browser here. So, okay, so we're parsing our chunk. We've got theoretically 22 bytes, and it's going to be this type, which is color profile. So type 1, which was sRGB, cool. Flags 0, what does flag 0 mean? Use special fixed gamma. So we're not doing that. Use special fixed gamma. I don't know what that means. If sRGB is special with special fixed gamma, it means this is linear sRGB. If sRGB is specified with one fixed gamma, okay. And then we're going to read the fixed gamma out. So gamma is 0. We're going to advance 8 bytes because we have. Did I not read the fixed? Oh shoot. Oh, I did read the fixed. Okay, so we're going to advance 8 bytes. And then type is not 2, so we're done. So now we're going to parse our next chunk. Oh, yeah. So something went wrong. So we're definitely not in the right spot. That's definitely not. That's definitely not a size that is real. Okay, something's gone wrong. Okay, why is it not working? Is the size? I'm gonna comment this one out because I feel like we should be able to advance let's see, I'm gonna go back over here, comment this out. I feel like we should be able to advance the bytes to the section that I care about. Maybe that's what we do next and figure out what's going on. So if we do this, else. Okay, so theoretically I should be able to advance to the next section that I want. And I should be able to advance by size. And the chunk information, as long as I'm reading the chunk information correctly, I should be able to advance through. So just to double check, the chunk size is dword and word. Is it the, okay, so maybe this is the problem. Is it that I'm not advancing? Is it that I'm advancing too far in that 22 is including the 6 bytes in here? So I wonder if I'm advancing too far. That could make sense. So if the chunk size is saying 22, and that's really just saying that's the size of this. Okay, so let's take a look. Let's rerun this. So we've got a chunk size of 22, and the first type, which is the one I just commented out. So we're going to advance 22 bytes. And we're going to go parse the next chunk. 32, it doesn't seem too off, but type is definitely wrong. So, okay, so we're definitely gone wrong in that advanced bytes. So here's what I'm thinking. is that advanced bytes is advancing either too far or too little. So the chunk size includes the D word of the size itself, is what it said. Okay, here, I'm actually reading the... Hey, Patrick, nice to see you. Thanks for joining. We're parsing binary files in JavaScript. It's very fun. The goal is to support the Aseprite native file format for Excalibur. So right now we're supporting the JSON format here, but I would really love for us to be able to use the native file format. So we're ripping through and trying to figure out how to parse the native file format. And we're building just a really rudimentary parser here to suss out all the binary fields. So fortunately they have a pretty well documented spec for all of the sizes of the binary fields. So we're going through and figuring out what's what. So right now, the problem I'm on is it seems like I'm advancing too far here in my parsing. So that first chunk read just fine, but now we land on an invalid type and size, so we're going too far. So looking at this documentation, the chunk size includes the D word of the size itself and the word of the chunk type. So the chunk size must be equal to or greater than 6 bytes at least. So what I'm thinking I'm doing is I'm advancing too far. So because it includes it, the parser already has read 6 bytes. So I need to subtract 6 bytes from where I'm going, is what I'm thinking. Because every time I read a byte, the parser advances the cursor. So I bet you that's it. So that's what I'm going to do. Let's see where we're going. All right, let's see how that does. So the first chunk, totally fine. That's a totally valid type. The next chunk, that seems okay. That seems like an okay one. Let's see, what is that in hexadecimal? 8217. (2019). Okay, that is a valid type. So if we look at 2019, OX 2019, palette chunk. Awesome. I think that's what it was. Awesome. We are now reading binary files. Excellent. So now we can advance again. Type 4. Type 4 doesn't seem like a right size. Or maybe it is. Let's see. Do we have type 4? Oh, we do. Old palette chunk. Ignore this chunk. Cool. So that is a valid palette chunk. Excellent. Let's keep going. Let's keep going. Cool. Now we're getting into pixel data. Excellent. We got pixel data. All right. So now we're in the cell chunk. Our layer index is 0. X position and Y position is -2 and 3. I don't know what that means. Opacity 255. Cell type is 2. Let's see what cell type 2 means. Cel Chunk. Compressed image. Okay, so compressed image is preferred. So, okay, so compressed image probably means we need to decompress. And if I remember right, they're using zlib. So, okay, so for, yeah, so, okay, so for cell type 2, we need to use zlib to decompress and see note 3. Well, I have a thing we can use, I think, for zlib. Let's see, note 3. Okay. Some extra notes that might help you decode the data. Okay, so we'll need to do some zlib decompression. Okay, so all right, so let's keep stepping through and see how far we get here. So we got z-index is 0, cell type is 0 here, but we're not going to go through that because we need to decompress via zlib. Okay, so let's go back to the code here and figure out what we need to do to decompress this as zlib. So basically, we're getting cell type 2, which is zlib. So I think I've done this before. Let's go to the browser. I've done this before for the other plugin for tiled, since you can store tiled data as zlib. Let me back up a little bit. I'm pretty sure. Yes, okay. I've done this before. Let's see what I did. Okay, so it looks like I'm using Pako. Okay, so we can use Pako to decompress this. So let's do that. Let's go look at Pako. zlib port to JavaScript, very fast. Why is it cool? It does all these things. Awesome. All right, so let's go see what I need to do. Is this the same one I'm using before? I just want to use the same one because I know it works. Sweet. Pako. I'm using an old one. Let's see if there's a new one. There is a new one. All right, let's do it. All right, let's grab Pako. Let's see, can I split? All right, so we're gonna grab Pako. So let's look at that spec here real quick and see what the data format is for cell type 2, which is compressed. So we have width and height in pixels, and then we have raw bytes that we need to grab. How many bytes do we need to grab? Does save exact set you up to never download a newer one in the future? Yeah, not unless you want to. I've been bitten by not exact before, where stuff just stops working. So I always save exact. But I have a lot of times what I'll do is I have Dependabot or what's the other thing I have going? I have automatic things that go and rev my dependencies and run CI. Yeah, if you don't pin them, I've been bitten too many times if you don't pin dependencies. Even though, like, theoretically it shouldn't break you, if you don't pin them, like, it should only be bug fixes. I've been broken before, and I've had builds just not work anymore, which really sucks. All right, so we got to read width and height here. And then we have to read a indeterminate amount of cell data. which I'm not sure how many bytes I need to read. Let's see, how many bytes do I need to read? Some amount of bytes, but how many? Compressed image, XY. How many bytes do I need to read? Well, I do know the length of the chunk, so I guess I could read till the end of the chunk. That could be a way to do it. Yeah, let's look at note 3. Yeah, not a lot of helpful there. Just that I'm using zlib and deflate. All right, so I know how big the chunk is, so I'm going to go with that. So let's see. So I know that my size, I know, let's see, I need number of, let's see, compressed image bytes is going to be some amount of bytes that I need to read. I know the chunk size. So we have the size given here. And I know how far away I am. I know how far I am into the chunk. I am this far into the chunk. I basically need to subtract the cursor position. I need to subtract the cursor position from the size to figure out how many more bytes I've got. Which kind of sucks. All right. Let's do that. So our current cursor is this. So we're starting here before we read anything. Then we read a D word and a word, which is 6 bytes. Then we're going to read, if we're in this type, we're going to read word, word, short, short, byte, word, short. We're going to advance 5 bytes. And then if we're in cell type 2, we now need to say, okay, what is our current cursor? In bytes, so we can grab that. And then I need to read current cursor minus, okay, so I have the, I have like how far I've read, and so I need to go size to read is size minus need a wrapper around the read functions that updates the byte counter for you. Yeah, probably. That'd be kind of nice if I could just get the byte counter out of them. Need a wrapper around all of the read that would update a byte counter for you. That would be nice. That way I could like just grab the current. Yeah, that would be nice. Yeah, that would be nice. Hopefully I don't need to do this arithmetic too much, because most of the time it's all fixed width, but actually I'm seeing this kind of thing here for the tiles as well. For these non-fixed size stuff, I'm going to need to figure out how to count bytes more efficiently. Let's see, where was I? I'm going to do current cursor minus this dot. Start cursor. So theoretically, this is the bytes I need to read. So this in this case is this parser that the idea is this parser wraps the or holds on to the binary data and then keeps track of how far along it is reading linearly through the array buffer and populating all of the data. So this is this guy. So, and we've got a lot of helpers here to help us parse through the different data types that are in here. We might refactor this API because it's getting kind of wild. We're doing it live though. Yeah. Yeah. Theoretically, that's how much I need to read. Let's do some experiments and see if that comes back with a number that seems reasonable. Let's set a breakpoint here, and I think I have a breakpoint right here in the chunk. Let's go ahead and hop right to it. And we are going to be in cell type 2. Well, I can already tell that those width and heights look completely unreasonable. All right, what did I do wrong? Okay, so that is a completely unreasonable width and height to get out of that. So let's see. Compressed image. Height in pixels. This makes me think like this is wrong. Unless I didn't read these right. Set to 0. Okay, let's compare. All right, so let's see. We got layer index, which is a word. We have 2 shorts, X and Y position, opacity, which is a byte. We have a cell type, which is a word, and it can be 0, 1, 2, or 3. Z index, which is a short. And then we have 5 bytes that we just ignore. Yeah. And then we do different things based on the cell type, and our cell type is 2. Makes me think that this is wrong. But then this would also be wrong. Number of tiles. Very interesting. Yeah, I am not sure what's up with that. They are D words, right? Oh no, they're words. Oh, okay. That's why it's wrong. Should be 64 by 64. So the size should be 64 by 64. So I just noticed I had a typo there. These are words, but I'm reading D words. So I'm reading too far. So this should be word. Yeah, and the sprites themselves should be 64 by 64. So we should see 64 by 64 here. All right, so let's see if that works. Let's go rip back through this. Error. What did I do? All right, let's try that one more time. All right, let's read this word. Ooh, interesting. 66 by 61. That's not what I expected. It's in the right ballpark, but not what I expected. Huh. Is that because... Yeah, I'm not sure. Is that because of compression? That's really interesting. That's not the number I expected to see. Okay. So, well, I missed my size to read. All right, let's log that out. Do a console log here real quick.
Make sure that's a reasonable number. Oh, you know, that's a good point. It might be because of that X position and Y position. That's a good point. I didn't think about that, but that seems likely to me now that you say that. Oh, we're still waiting for it to build. Here we go. Yeah, okay. That does make sense now. Because if we read this, 66 minus 2 brings us 64, plus 3 brings us to 64. Okay, well, that was a really great observation. Yeah, that's awesome. Yeah, sharp eyes. All right, so let's see if our size to read is anywhere. That seems like a reasonable amount of size to read. 685 bytes. Cool. Let's try to read that with Pako. All right, let's see how to do Pako. All right, we require it. We give it a uint8 array, and we pass deflate, and then we get our output. Excellent. Let's do that. All right. And I want types, so let's do that too. Does Pako have types? We'll find out. If it doesn't have types, I'll import them. Let's see, import Pako. Am I getting anything? Do I have any types? I do. Yes. Yes. Cool. I have a deflate. And data is uint8. Okay. Or an array buffer. Pretty cool. All right. So I can do that. But it is complaining. Deflate is declared. Could not find declaration file. Oh, I guess it does want types. Interesting. Why is it complaining? Oh, this just looked like TypeScript to me. It's just JavaScript. Okay. So let's get the types. Is deflate compress and decompress? Oh, maybe it is. Deflate, inflate. Oh, you might be right. Yeah, no, you got it right. I just have it. Deflate in my mind, I read as decompress. You're saving me a lot of time. Thank you. I want to inflate. Thank you, thank you. All right, let's grab the types. There we go. Now we got some types. All right, and then we need to just grab our bytes as a uint8 array. Inflate. So we're going to inflate some data, and we need to add a facility to slice this off of our current data view. So let's see. I'm going to call it get bytes, and then it's going to give us a uint8 array. Uint8 array. Oh, nice. Yeah.
deflate and inflate. Yeah. I tell you that those words are conflated in my brain with compress and decompress. So I went deflate to decompress, and that's the mind killer right there. DataView. Let's see, can I get a slice off of this, off of DataView? Let's see, what do I got? I can get single bits. Can I get a slice out of an array buffer? Slice. Yes, I can. I can get a section of an array buffer. So I want an array buffer from this.cursor, and I want n number of bytes. Begin n. I imagine these are indexes. We'll find out if I'm wrong. And then I want a typed array. All right, let's try that. So I can get some bytes. Let's see if I can get some bytes that look like pixels. So I want to get that many bytes. And you know what I'm going to do? Well, yeah, I'm going to get those bytes first, and then we'll inspect them. All right, cool. All right, so theoretically, I've got the right number of bytes to decompress. And then the question is, do this, after they're decompressed, does it look like pixels? Which we can read. They're 2-byte RGBA. So we got four bytes. So we need to read RGB and A. If end is unspecified. Yeah. Yeah. And I don't want to read to the end of the array buffer because this is the whole file. So I only want to read to the end of my chunk. So I want to read a very specific amount of bytes since I'm in the middle of a file at the moment. There's a compressed bit in this file. All right, let's see how that looks. Let's see how far we get. This is fun. We're getting to the fun spot. All right, it's still building. All right, let's skip to my compressed. There we go. So we're going to read 685 bytes. Sure, we'll go with that. And we got 685 bytes in a UN8 array, so that tracks. Let's see what happens when we decompress them. Oh, except I need to add a little helper here so that we can see what we got. All right, let's try that one more time. All right, let's see what we got in our decompressed. Maybe. Do I have things that look like pixels? A lot of zeros. That's not a bad sign, but it's not a good sign either. We got a black. And keep in mind, we should be seeing like something like this. So this is our image data. We should see, like, for frame 0, we should see something in the blue or white territory. So I guess that was white. Wasn't that white? That's 255, 255, 255. So we got a 1 white pixel. Okay. Let's try to get in the middle of the pack here. Okay.
RGB, mostly blue. Yeah, that seems right. This seems like blue. Seems bluish. Okay, that seems like the right colors. RGBA, RGBA. It's a lot of repeated 22s. It seems okay. Well, what we can try to do is see if we can't write that to a canvas and see what it looks like. And just drop it to the window, just for debugging. That way we can tell if we got actual pixel data. Yeah, let's do that. Let's do that. Oh, I wasn't showing you the middle of the pack here. Let's see. There we go. Looks like it might be right. If this is B or A, this is RG, or maybe this is A, so it's RGB, A? Maybe? We can, here, let me pull it up in Aseprite actually and just sample the pixel color and see if that looks anywhere close. Yep, that's it. That's totally it. So let me switch to Aseprite here real quick. So we're totally getting the right pixel color. So I get kind of the middle of the pack here. 22, 22, 211, 255. Oh yeah, we're reading pixel data, baby. That's what you like to see. You like to see pixel data. Let's see, which one was I on? One of these chromes. So that's totally what we're seeing in here. So awesome. So we totally are getting pixel data out. So let's get oriented here and in our victory of reading pixel data. And thank you for catching my bugs as I was going. All right, so that is, dang, that's all the cell data. Sweet. All right, so let's actually grab and let's actually make this into canvas. So, so I'm just gonna grab. Let's see, how do I do this in a non-problematic way? Well, I'm gonna do it in the problematic way first, and then we'll figure out how to do it in a non-problematic way. I'm just gonna make a canvas. So we just need to make a canvas element. We're just gonna, that's what it's gonna be. This dot canvas, let's document, create element, canvas, context equals this dot canvas, get context, 2D, and so we can set image data and stuff. So that's what we'll do. So we'll get the image data and we'll be able to set it. See, so let's see, can I do a set image data? There's a way to set image data. Hold on, let's go look it up. Canvas, set image data. Put image data is what it's called. That's a name. Let's see, and can I create an image data? Create image
image data. Cool. So I can create image data and then set it. Okay. So let's do that. All right. So in here, since I know all of my pixels, I'm going to, I know it should be 64 by 64, so I'm gonna fudge it. Context, create image data, 0, so what is this, width, let's see, Endian, create image data. Width, height, okay. So I'm gonna do 64 by 64 real quick, and then we'll figure out, oh, what settings do I have? I don't know if I need any settings. Create image data settings, color space. Oh, I don't care. We're just gonna use the default color space for now. Okay, so we got some image data. Kunst. And then we need to set some pixels. Data. uint clamped array. One-dimensional array. Can I just do that? No, that would be too easy. Cannot assign because data is a read-only property. Okay, if image data can I do this? Uint. What is this type? Uint. Well, it's read only, so I can't do it anyway. Yeah, so it's going to be like, okay, can assign read-only property. Okay, so let's see. Can I do a copy? Ooh. No, this returns this object after copying. Can I do a fill? No. Ooh, I can set it with an array like. A typed or untyped array to set. Let's do that. Neat. All right, so that should set the image data to our decompressed value. And then what I want to do is grab our context and put image data and I need to give it a spot. I'll just put it in 0, 0. So we're going to put our image data, and then that should basically make it so that canvas has all of our image data. So I can just to make sure that we're getting everything right, I should be able to drop this onto the, just for debugging, I'm just going to drop it right onto the screen. Oh, new image data array width and height rather than create image data. That would probably be better. Let's do that. Uint clamped array. Uint clamped array. Can I give it an array like? Oh yeah, cool. That I think would be better. Let's do that. All right, so we got our image data. do that. And then we don't need to do that, or that, or that. Cool. All right, so let's see if our image data shows up on the screen. That'll be a tremendous victory. Waiting for it to build. All right, something's not building. Input data length, not a multiple of 4. Dang. All right. Let's take a look. Yeah, it is indeed not a multiple of 4. 16104, is that not? That's not a multiple of 4, right? Oh, it is. That is a multiple of 4. Okay, why is it upset? (64 by 64). Okay. Interesting. So, okay, so it's upset about something here. Error loading, Failed to construct image data. Input data is not a multiple of 4. 4 times width. It's not a multiple of 4 times width. Okay, so I think there's maybe just a mismatch here in what our compressed or decompressed data looks like and what this is expecting. So let me just suss this out so I'm not doing so much in the same line. (64 by 64 pixels) data decompressed. Yeah, maybe it might need to be some of those other numbers. It feels like there's a, like this is, because it, what is it? Should be 4096 pixels times 4 for each component. So it should be this, right? Because that's, if we have a 64 by 64, it should be that. But if we are to believe the parsing, then it's not that, and that's not what we see in the debugger, right? We see 16104. So maybe we do need to do 66 by 61. Okay, so let's do some math. So 66 by 61, what do we get then? Okay, so then we get the number that we should see. So we do actually have to use the width and height here, theoretically. Yeah, I am not sure why it's not 0, 0. Like, let's look at the Aseprite, and maybe there's a clue. Nothing's really jumping out to me. 64 by 64. I mean, it says it's 64 by 64. I wonder if it's a weird quirk of like an internal representation or something. Or I wonder if it's saving some space because I'm not all the way up to the edge here. But then one of the dimensions is 66.
Yeah. Yeah, because like X and Y position, I look at the, oop, wrong one. We look at our X and Y here, -2. Yeah, that's, I don't understand that. That's very strange. Well, let's see if this works. And then we might need to understand that in negative business, -2 and Y is 3. That's very bizarre. I don't understand that. Okay, so we got our decompressed. And that should match up with the width and height now. Okay, so now we got past that. And we're sRGB. All right, so now we should see something on the canvas. Huzzah, we see something on the canvas. I'm already noticing something interesting. Weird. There's like a weird split here in the tail that I'm not seeing in the first frame here. Weird. Well, I'm really impressed that we're reading the pixel data out. So I'm very pleased so far. Now, I'm wondering if this is maybe where our let me make the background a color so we can see. I feel like there's some extra goo in here that maybe that negative positioning would account for. It's still pixely. Oh, I need to do image smoothing to false. Okay. Wow. I'm very pleased with this. X position of the grid. What do you care what the grid is? Yeah, I don't know. I'm not sure. -2. That would put us back here. And that's where we're getting that weird blue artifact. Like we're back here by 2, right? Interesting. Let me noodle on this real quick. Let's see. -2. That's very interesting. I'm not sure what that means. Let's go back to the spec here. Let's see if the spec has any like hints as to why this might be negative. Aseprite spec. Here we go. X position, Y position. It does not.
We got layer. Well, let's see if there's anything in the notes section at all that gives us a hint. Layer is just for, okay, for doing layering. We did this, okay. Yeah, that is very confusing. I don't understand why they, oh, let's see. Oh, is it the cell's position in that frame that the cell might translate itself natively apart from the location in the image? Oh, I don't know if I understand what you mean. Cell's position in that frame. Oh, okay, so I see. So, okay. So the cell, guessing, is it like the bitmap exists independent of the frame, and we need to translate it to the left to each frame of animation may render at different positions. Yeah, I think that's true. Yeah, I think that is true. Yeah, I think that's true. So that must be what it means, I think. So, okay. Oh, this is interesting. So that means we need to translate the canvas. Oh, this actually makes it easy. This actually does make it, this makes it, okay, we can fix this easily. If this is just the translation of the image that we put on there, we should just translate it by the X and Y position. I think you're right. Yeah. I'm really glad you're on the stream. You're helping me out a lot. Okay, so let's do that. So we can translate our X position, Y position. So we should be able to just do that. And that should put us right. So, okay, so the cell is independent, but the canvas needs to be the size of the final. Okay, we'll figure that out later. It needs to be 64 by 64 at the end, but I think you're right that it is a translation. That's why they pay you the big bucks. I'm glad. All right. Let's go back over here and see if that fixes this thing up. Let's see, did I translate it the wrong spot? I gotta translate. Okay, do I need to, okay, when you put image data, does it get affected by, it doesn't get affected by transformations, does it? Because we are directly modifying the image data in the canvas. So if I want to translate, okay, let's see. Put image data versus draw image. So I think I want to do draw image. Can I draw image with, here, Endian draw image, image data. Can I draw image with image data? Because I want to an image bitmap. Because I want to draw an image, but I want it to be affected by the translation. Because right now, put image data, I'm just affecting the okay, I can create an image bitmap from image data. Because I'm just affecting the backing canvas or the backing data structure, so it's not going to be affected by the translation. Okay, so we get a bitmap. translate. Why don't you like it? Oh, I need to create, sorry, I need to call create image bitmap, which just exists on the global scope. Cool. So I can create an image bitmap, translate the canvas, then draw image. Actually, I probably could just draw the image at the minus. I could just draw it at the -1, probably. Oh, I need to await this. No, I need to wait it. Oh no. I gotta do async parsing? Oh, probably not. You know what I could do is, since I'm only doing this for debugging, we can just do the rest of this. In here. Yeah, this is just for debugging anyway, so I don't really care. Okay, so we can translate the context and draw it in theory, and then it'll be drawn theoretically in the right spot? Question mark? We'll find out. Looks like it's drawn in the right spot. Huzzah! I think you nailed it. So thank you. So another thing we could do instead of translating, I think we could just draw it in the different spot, which might just be cleaner. Yeah, that works too. There we go. First frame. Huzzah! We got the frame. Very cool. Okay, let's orient ourselves. Let's see where we're at here. Let's look at my to-dos here. For each frame, how many frames? Read the frame header. We're doing that. We're extracting pixel information. Huzzah. And we need to produce an Excalibur artifact. So we're pretty close here, apart from it being broken right now, but we're pretty close because we've got basically all we need to parse. So we've got our pixel data now per frame, theoretically. All we would need to do is create some Excalibur image sources and produce an animation based on the parameters that we got from parsing. So we just need to do that. And then we're done. Yeah. Yeah, I agree with you. That's probably why they do it. Cool. All right, so we're pretty close. We're pretty close to our end goal here. So let's clean this up a little bit and get there. All right, so we don't need this anymore. Don't need this. I am going to comment. Let's see. Let's just close that. I'm not going to do all the other parsing right now. I think this is going to be good enough. I mean, I'm going to have to do the other parsing to finish the plugin, but I think this is going to be good enough for the stream. What I want to do is get this working like the other data, the JSON-based plugin. So all we need to do right now is squirrel away for each frame. We need to squirrel away our image data. Yeah, so for each frame we need to squirrel away our image data. I'm tempted to do a canvas per frame and then draw. Yeah, I'm tempted to do a canvas per frame and then draw the images to the canvas, because we know how wide and tall our animations are. Let's see, what does header have here? So we've got width and height. So this is our actual width and height. So this is that 64, that it should be. So this should be the height of all of our canvases, height and width of all of our canvases. Okay, so let's do that. So I'm gonna squirrel this away. But first I'm gonna fix this typo. So once we've parsed the header, we know the dimensions and the number of frames of frames. So we're parsing the frame. So as we parse the frame, we could just create a canvas for each frame that we parse. Why not? That works for me. I think there's a limitation. So this could be problematic because there's a limitation to how many canvas contexts you can create. In a browser before they stop you. So if you had a lot of frames, let's see, how many canvas contexts can you make? In a browser. Let's see. Let's see, maximum canvases. No, there's maximum canvas size. But maybe I can create as many as I want. Well, it looks like we're limited on size, but not number of elements. Oh, there's a lot. Okay, I'm not worried. I'm not worried anymore. I think we'll be fine. What I probably want to do is create an element and then grab a context. And then I'm just going to do image smoothing false. I don't know if that's going to be important. We're going to assert that I have it. All right, so canvas rendering context, we'll push a context. I have it, I promise. I promise it's there. Okay, so we're going to have each canvas frame. You know, I could parse, you know, what I should do is I probably should just pass this in. so that I don't have to rely on the global. Yeah, I probably should, but I'm not going to. All right, and then I know, actually maybe I will. I either need to pass it in or I need to pass in the frame index. So I think I'd rather just pass it in at that point. Cool. So there's a canvas rendering context. And then we'll pass that down. Oops. We'll grab that. We'll pass that down. And then in here, oh yeah, maybe I just return that. Yeah, maybe that's a better way to do it. Yeah, these chunks though aren't always. Yeah, this is tough. These chunks don't always return stuff though. Let's see. Maybe that's the case. Well, I'm gonna have to asyncify this anyway. All right, we're gonna asyncify this real quick. We don't need to append the child anymore. And then we're not gonna do this context anymore. We're gonna do this. I'm gonna go clean this up here. Yeah, I might have to refactor it later if I decide that I'm wrong about how this works. So clean this up. We don't need this anymore. Don't need this. We've got our width and height here being set. Maybe these are public. No. All right, so we got our frames. We got our width and height. That should be drawing that to that. We are not parsing nearly everything, all the other things that can be in the chunks for a particular frame. Let's see. Is that all I need to do? And then I just need to assemble the same API that there was before. So the same API that's presented is I have this raw frames. I might cheat and not do it all for now, but it'll get us pretty far. And then I have image, which will be embedded, so I don't need this anymore. So I won't be able to do exactly the same API, but it'll be close. There's an image source. So all I really need to do is get the sprite sheet, produce a sprite sheet, produce an animation. Okay, we're close. All right, so we need to await the parse now. Okay, so parse frame header doesn't have any sync. Cool. We've got our width and height. We've got a couple of to-dos in there. We've got our stuff read and stuff out. Cool, cool, cool. All right, let me look at my to-dos here. I'm losing track of what I'm doing. All right. We've got that information. Okay, so we just need to produce an artifact. All right. So let's do that. So we just need to make this work. Okay, so if it's loaded, this.data is sprite sheet. Okay, and then we have a sprite sheet given some information. Okay, so we need to be able to build this sprite sheet, but it's using the old API, and that's what we're using here. So it does this.data. Oh, do I want to do an overloaded constructor? Those really suck. Maybe I won't. Do I ever pass this this data is available? Shoot. I don't know how I want to do this. Well, let me work backwards. I know I can get the animation to work, right? And the sprite sheet. So let's work that way. If this dot type is JSON, we're going to do the old thing. Else, we're going to do the new thing, which the parser we need to grab this from Excalibur, not the browser animation. An animation is just a sequence of graphics. Frames. So we should be able to get all our frames out here. And we know the duration of each frame from our parser. So we just need to expose that information. So let's go take a look at our parser here. I'm just going to make it available at the top here. Probably a nicer way to do this. Native parser. We're going to load native parser. And then, okay, what do we need to expose for animation? We need frames, and frames take a graphic, right? It's a graphic and a duration. It's a graphic and a duration, cool. So let's do that. So we have our canvas frames. We need to get frames, and we'll just return this dot canvas frames. So that should get us all of the frames. And I'm going to make this public because I want the width and height just available to us. I want the number of frames. What else do I need? I need duration. Where it is the duration of the frame. This is deprecated apparently. Let's see, duration. Frame duration. Okay, so for each frame, you know what I could do? I could just output this as an Excalibur frame. Why don't I do that? Let's do that. Oop. I want to squirrel away the frame duration, so I wonder if I can make these as I go. Instead of doing this business at the last minute. So after I've parsed the chunks, we can go ahead and push a frame. We have the frame duration milliseconds here, and then we have our graphic, which is going to be our context canvas here. Then we just need to figure out how to get that into a graphic. Let's see, I think I can do, let's see, how do I do this? Let's go look at Excalibur. How do I turn a canvas into an image source? So what I want to do is I want to take a canvas and make it into an image source. So let's look at, I don't want to look at the test. I want to look at the image source. I could make it, I could make it into an HTML image element. That might work. It really wants to load it from a path. It really wants to load it from the path so that it can do its thing. I could turn it into a base64 string. That actually might be what I need to do to make this work. It's kind of a hack. Yeah, I think that's what I'm going to do. I'm going to make it into a base64 string so it can be loaded. And it'll still follow the same pathway. Let's see, canvas to base64. I think it's I've done this before. To image URL. What is the API? To data URL. I've done this before. There we go. To data URL. There we go. So we'll get, we're doing this kind of in a roundabout way. I wonder if I need to make a different, it would be nice if I could do, maybe I'll have to add something to Excalibur to allow you to use like canvases as image sources. I think that would be useful. So I think that's a thing that I'm going to maybe add to Excalibur, but this is kind of a hack to get us around it. do that, image source, and then we can do image source to sprite. But I also would like to load it. Okay, so that should work. That should work. Yes. Oh, oops. And then if I go back here, yeah, it might be null. Then in animation, I should be able to return this native parser get frames. Currently, I'm not getting it by the tag of the animation. Shoot. Oh, you can only see the browser. Thank you. Sorry. Okay, so here's what I did. I ripped through and did this hack to make the image source thing work with Excalibur's graphic concept. However, I'm not parsing the tags yet, so I can't grab a specific animation name, but I'm gonna basically just treat all the frames as one animation. So we'll see. Yeah. Get animation, get frames. This is just a frame though. This is not a. Why is this allowing me to do this? Oh, it shouldn't. It should give me an animation. There we go. So I need to return a new animation. I assert that they are frames. Okay. And they have durations on them. Let's see what other options I have here. Animation options. Okay, so I don't have any of the reverser, the ping pong stuff set up yet. So let's see if this works. Let's see if this works. Does not include undefined. What? Okay, there we go. Since I gave it a type now, it wants it to be loaded. Okay, so let's see if we get stuff. I got a bunch of errors here. No, I got errors. Animation is not loaded. Okay, so we've got a bug. I broke something. And it looks like it's something async because there's a generator in that stack trace. Okay. Well, let's step through it again. A little too overzealous with my refactorings before testing. So let's see if we can get through the parse. Let's just start there. Parse header. Okay, we have 3 frames. We're grabbing some canvases. We're going to parse a particular frame. Oop, and we died right there. Huh, we're not making it in there.
Why is that happening? Let's see. Is it because I'm awaiting inside of a for loop? Async parse frame. Huh. I'm not getting inside that. Oh, now I am. Makes me nervous. Okay, so we're parsing the frame. Weird. Is it just a weird source map thing that's going on right now? Range is out of bounds. Okay, so I'm bombing in Parse Chunk. Let's make sure that we can get back in here. Okay. So far, so good. Okay, we're getting the bytes still. We're still decompressing. Okay, so that's still working. We've got our image bytes. Oop. Come on. Don't do that. Don't Google search it. It's because it's in quotes. There we go. Cool. And then we're getting our image, so that's good. So that looks fine. We're loading. We have our image source loaded. It is ready to go. Interesting. Why is this? Why is this bombing then? Well, that's definitely out of range. I wonder if there's something weird async happening. Like I missed a wait, an async or an await. Well, it's mostly working. Let's see. Let's go back to the code. Let's just follow it through here real quick and see if there's something obvious that I missed. Okay, so we're going to do parse. Parse header is not async. There's nothing async in here. Right, there's nothing async in parse header. Once we parse the header, we know the frames. We're going to parse the frames. Parse frame is async. We rip through and parse all the chunks. Parse chunk. I'm not sure why it's failing. let's rip through it. There's probably something silly. You know what it is? Oh, I know. Here's why. The cursor's at the wrong spot after we read the image data because we didn't, because we sliced on getBytes. We don't actually advance the cursor. So that's why it's broken. So this is like a CQRS violation. I might change this later because getBytes, well, everything else advances the cursor, so it's going to be consistent. I should make this like read bytes or something. Okay, so we're going to read the bytes instead. So we'll advance the cursor by n. So if we read the bytes, the cursor gets advanced by n. Plus equals return data. Okay. That was I made a mental note in the back of my mind about that, but I forgot to follow up. Okay, so let's refresh here and see if that fixed it. All right, looks like we loaded okay. Animation not loaded. I don't know why everything is all... Oh, is it because I'm zoomed in? It might be because I'm zoomed in. Okay, there we go. This might have been the wrong move. Let's get rid of that. Okay, well, it doesn't load, but we're getting closer. Let me look at what we got in main here. I want to get Aseprite resource. See where we are at. Okay, so we're definitely loaded. You know what I didn't do is actually return a resource. So I think that's maybe why it's thinking it's not loaded. Yeah, that's why it thinks it's not loaded, because there's no data in the deal. Okay, so that's why it's thinking it's not loaded. So data, it wants a sprite sheet. So right now I'm just gonna lie. I'm gonna keep the fix me, because what we got so far, what we got pretty good on, is we're now downloading the native Aseprite file, parsing the little Endian headers and data information. We've got the pixel information. We can load that up in the frame, so we know that that's working. We just are falling flat here on the, extracting the animation format and producing an Excalibur format or artifact. So here's what I'm gonna do. I think we're gonna stop we're gonna pause right here and we'll follow back up. Hello, happy Thursday. Today we're gonna talk about Aseprite again. We're gonna be hacking on Aseprite again. Last time we got pretty far. we were able to download the native Aseprite format. We can parse the data in little Endian using that DataView DataView thing from JavaScript, which is super useful. So we're doing that. We got pixel data, and where we left off last time is we got stuck at a invalid abstraction. So the abstraction that the plugin uses for sprite sheets didn't serve us anymore, and that's where we got stuck. So off camera, I did a little beep booping to make that abstraction work for us, and I changed not much. So the gist here is, instead of this constructor that we had before that was assuming, that we'd have the JSON representation. That's what this type is. The JSON representation, and then the flattened, sprite sheet image, which isn't the case anymore. I moved that into like a static builder, and just for clarity, I made the constructor empty. Now there's a little bit of hokey pokiness here where we're setting things manually. We can probably fix that later, but for now, that made everything kind of shake out. Required the fix to the tests, and then fix to the resource. So if we're using JSON, we're going to use this new builder. Otherwise, we still have a empty sprite sheet over here. But that got us to the point where things are loading now. So if we go take a look at the browser now, we can see that we are indeed loading the native Aseprite format, and it is close to the animation, not quite the animation that we have. So if I take a look at this here in Aseprite, so you'll notice that the animation is kind of going one way, and if I go to Aseprite here, the animation is configured to ping pong. So there's some of that that we need to fix today. So we need to figure out the tags chunk to get the ping pong. We also need to figure out multiple layers. So I don't know if multiple layers are working. I have a feeling they're not. So if I add a second layer, is it going to work? It's dubious if it will, because looking over here at Aseprite, we're only using one layer. So it's if I add another layer here, draw something on it, will it render properly? I'm not sure it will. So we need to figure that out. Multiple layers, make sure that those work. And then we have some refactorings that we want to do. We've had a lot of, fix me's and a lot of to-dos in here as we've kind of just ripping through to try and get something on the screen. So let's take a look and figure out. I might actually reorder these because I think we're going to need to read the tags chunk in order to read an animation. So let's go look at that. So let's go over to the browser here. Go look at the spec for Aseprite binary files. So I'm going to go ahead and just paste that here in the chat. So if you want to follow along and read the spec, you can. So we last time we're reading the Cel Chunk, and that's where we have this compressed
image data. So that's what we read last time. I'm going to ignore tile mat for now and move on to the tags chunk, which is what is going to tell us like what kind of animation type is it, you know, which frames are part of the animation, does it repeat, you know, some extra special stuff here. There's I don't think we're going to need this, but we might need to read into the user data chunk, which is additional data that can be appended after a particular chunk. So in this case, it says that you can have a user data chunk for each tag chunk, or each number of tags. So I don't know if we'll need to use that. It looks like it's extra fluff for the editor, but it also looks like it stores some arbitrary properties, so we might need to dig into that. But it looks like we have everything we need here on this chunk. So if we can get away with it, I might just read the tags chunk and then, you know, be done with it. So yeah, so I think next I'm going to read the tags chunk. So let's go do that. So let's hop over here to Le Code. And let me switch back to the non-diff here. Let's get rid of this in the side. Okay, so we are reading, this is the Cel Chunk that we just read, and then the tags chunk is this one. So let's go read the tags chunk. So I'm just going to reorder these. So else if type equals OX 2018, fine year 2018. Then we're going to read the tags chunk. So let's take a look at what we got here in the spec. So first thing in the tags chunk is we need to read the number of tags. So that's a word. So we'll read that out of there. We have 8 bytes of nothing. So we can advance 8 bytes. We got 8 bytes of nothing. And then there's this spot here that says for each tag, we're going to read this. So we're going to have to do for each number of tags. So let's do that. So for each tag, for 0, I less than number of tags. Also, we probably need to increment that I. We're going to read our from frame, and that is a word. We're going to read a word out of there, and then our to frame, which is another word, out of that file. Now we have a byte that is the loop animation direction. So this is like if you play forward, if you are reverse, ping pong, or it's ping pong reverse. So that's a byte. So animation direction equals this dot read byte. So we read that byte. Then we have how many times it repeats. And that is another word. And then we have 6 bytes of nothing. So we'll do 6 bytes of nothing. We have RGB values of the tag color, but we don't really care about that because that's for the editor. So I'm gonna say we're gonna ignore that. So we'll advance 3 bytes for that. There's 1 extra byte hanging out on the end. And then there's the tag name, which is a string, which is interesting. So how do we read a string? So this last thing is the name of the animation. So this is actually super important for us to get. So let's look at what they consider a string here in there. Okay, so a string is first preceded by a word, and then that gives us the length in bytes that we need to read characters out. And then there's a null terminated character not included. Does that mean we need to advance past that, or what? So the characters are also in UTF-8. Okay, so we need to build a parse string function. So let's go do that. Let's go build a read string. Private read string. And then I guess we can just leave it as that. And I would really like it to kick out a string at the end. So that would be super cool. So in order to read a string, we need to read that first word that tells us how long it is. So we're going to read a word. So that's our length. And then we need to read bytes. And theoretically, that's handled by this function, read bytes. So string bytes is this dot read bytes length. And then we need to interpret those bytes as a string. So let's ask the Google how to do that. Interpret byte as string JavaScript. I want to convert. I want it the other direction. How about convert bytes to string? That's what I want. Let's ask this. Ooh, interesting. There's from char code. Will that work with UTF-8? That is a strong maybe. Okay, let's go look at Endian. So okay, so we have from char code. Static method returns a string created from specific sequence of UTF-16 code units. What about from code point? Static method returns a string created by a specific sequence of code points. I think this is what we want. Maybe? That's a good question. Well, we can try from char code, but I'm not sure if, because it uses UTF-16, if it's going to work. I honestly don't know the difference between UTF-16 and UTF-8. They are different. Characters in UTF-8.
Oh boy. Okay, so this looks interesting. All right. UTF.js. We can convert an array to a string. Oh my goodness. Oh. Text decoder. Maybe this is better. Oh. I think I like this way better. Is this part of the browser? Oh, this looks way better. This looks 100% what I want. It looks like it's compatible too. Oh, we should use text decoder. This 100% looks like what I want. Let's do this instead. All right, so let's try that. Let's try text decoder. Okay, let's see an example here. So for text decoder, I need to create a new encoder or decoder. And then I need to decode my buffer source. Well, I have a buffer right up here. Can I just use that? Looks like I can. What? Did that just work? Wow, that's a lot easier than I was hoping for. Who knows if that actually works, but if it does, that would be real dope. Now the only question I have in the spec that makes me worried is if I have to read the null byte at the end or not. The null character is not included. Makes me think that I need to read an extra byte. Let's read one more byte. Make sure that's the null byte. We can console log it. Cool. All right. Hey, Chris. Nice to see you. It's going well. Let me show you what we got so far. We've got stuff. If it builds, or if it's no longer building, we're crashing somewhere. But we did have stuff displaying on the screen. So before that, it's going well. Let me actually comment out. Let me comment it out real quick and prove that we had stuff working. Just comment out this whole block. Maybe it'll work. Yeah, there we go. So yeah, so we now have all the frames coming through, and we're reading all the pixel data out, which is A+. The thing that we're missing is we're missing the tags on the animation. So if we wanted to get at like this loop animation, we don't have that. Directly from the native Aseprite file, so you don't have to export it to JSON. So yeah, it's coming straight out of the Aseprite file, which is pretty slick. So right in here, we're loading up that native file. So that'll be a huge time saver, so you don't have to go through and make sure that you export it the right way and stuff. So I'm really excited about this. We're making good progress. It is kind of a pain to parse the native binary, but we're working through it. We're working through it. Yeah. So let's figure out where we were there.
let's see, where was I? Native parser, undo. All right, so now I need to read a string, which is the tag name. So theoretically, we have implemented the right way to read a string out of the Aseprite chunk, which is when you read a string, there's a word that tells you how long in bytes the string is. And looking at the spec, this says the length, the null byte is not included. So I'm thinking I have to read an extra byte here to make it work. But we'll see. Let's set a breakpoint here and see how far we get. Well, clearly I'm out of bounds somewhere, so something is wrong. Let's see. I want native parser. I want to read this string here. All right, so let's refresh here and see how far we get. All right, so number of tags, only one. Okay, we're gonna advance 8 bytes. We got 1 tag. Our from frame is 0. Our to frame is 2. So that tracks. We got 3 frames, 0, 1, 2. Animation direction should be ping pong. So 2, what is 2? Let's make sure that we got that right. And that would be in the tags chunk. 2, ping pong. Okay, so that's right. And then we have random bytes here that we're ignoring. And now we're going to read this string. So we have a string length 4, which makes sense because the word loop is the name of that animation in Aseprite. So we're going to read the string bytes out. LOOP. That looks like maybe that's right. And then we have a null byte. Is this the null byte? I don't know if that's the null byte or not. Let's see. What is the null character? Null character is encoded by 2 bytes. Ooh. Maybe that's a problem because this is UTF-8. For instance, in UTF-8, however, modified oh, hold on. It's a single byte. Okay, let's read the Wikipedia article. Whoa, we're really zoomed in. Okay, let's see. Null character can 2 bytes. 0C. Okay, let's see what that is in decimal. $192. Is that what we got out of there? We got 199, didn't we? I don't know if that's right or not. What was the other one? Oh, I'm not very good at reading hex, so 128. It's neither of those. Well, I either need to read the extra byte or I don't. So part of me is thinking that I don't need to read it now because it doesn't look like a 0 in it. I would expect the null byte to be a single octal digit 0. As a consequence, it must not be followed by any of the digits 0 through 7. Yeah, if I'm reading this, it makes me feel like it should be like a 0. Unicode, there is a special character for the symbol. All modern character sets, the null character code point has a value of 0, which makes me feel it should be a 0. In most encodings, this is translated to 0 value. If UTF-8 is a single 0 byte. And we are parsing UTF-8, so that makes me feel like I shouldn't read it. When it says it's not included, that means I don't read it. So I'm going to not read it. We're going to switch back over the code here and not read that byte, because I think that's just the start of something else. Okay, so we're not going to read that byte. Okay, let's see what we're at now if I set the breakpoint here and see what I do. All right. Well, it didn't break, but it didn't break on my breakpoint. Okay, okay, there we go. Okay, so we got our decoder. We got our bytes. Do we get loop? Oh, we get loop out of it. I've never been happier to see bytes converted into a string. Sweet. Awesome. So now we're reading the tag out. So we now know which animation is which. So, all right. So when we read an animation out of here, what are we going to do with it? Well, we need to keep track of the name of the animation, the type of the animation, whether it's repeating, and it's to and from. So I basically need to keep track of all this metadata in a data structure. So what I think I'm going to do is I'm just going to keep track of I'll just keep track of the tags as a map of like the tag name, which is string, and then we'll have a data structure that we'll keep here. So so we'll call it an animation tag. So it's from number to number, type number. Yeah, actually type we can do what is it? The animation type. What is that called in Excalibur? I've already forgotten. Let's go look it up. Ping pong. Animation strategy is what it's called. Cool. So we have ping pong, loop, and freeze. Okay, cool. So animation strategy. What else did we pull out of here? Repeat. I think it has a number for repeats, like the number of repeats. Let me look at the spec here. So we want repeat n times, plays n times. 0 means infinite. Infinite in UI, once on export. For ping pong, it's once in each direction, plays once, plays twice, okay, plays n times, okay. We'll grab the repeat, okay, and then what else do we need? And then we have the name, which we'd know. We gotta give it a name. I'll put the name in here too, even though we're looking it up by name. It might just be useful to have the name in here. So we have an animation tag. Tag. So then when we parse, we can just fill that in as we go. So we have our tags. We're going to go and set the tag name. And we're going to fill in our animation.
our tag name, we got our from, we got our to, we've got our type, which is an animation strategy. So let's do a little let type. Let's figure out this type. Animation strategy. We'll just give it a default one. I think the default is it plays once, and then does it disappear or end? I think end is the default. We can fix that later. So if animation direction, which is the type, equals 0, I'm going to make this a switch case. Case 0, type equals animation strategy is forward, which is just end. So that's case 0. Case 1 is reverse. So I think that's end. We don't have a strategy reverse, but we do have, okay, maybe I need to not, okay, you know what I think I need to do is instead of doing this right now, we can set animations to be reversed later. What I think I'm going to do instead is just store the direct like constant here as another type. And we're gonna map it from forward, reverse, crisscross, ping pong. Ping pong reverse. Okay. So we're just gonna keep track of the animation types. Do I want to do this as an enum? Nah. So in here, then we're just gonna make this a number for now. Yeah, we'll just make it a number, and then we'll use this later to figure out which way we want to do it. Because in Excalibur animations, you can do forward and ping pong, but reverse is like a separate property. So there's not, you can just, oh, thank you. Yeah, we're not looking at the VS Code. So sorry. So what I was talking about there, and thank you for pointing that out. Forwarded and reverse, or reverse is just a separate property in Excalibur where you can just like set reverse on any animation and it'll reverse it to, regardless of the strategy, like versus ping pong or whatever. So we'll just have to map how Aseprite understands animations to how Excalibur understands animations. So for right now, I'm just gonna grab the number out of Aseprite and just use that. Animation direction. And see, what am I missing? Probably repeat. Cool. And there's a sweet trick in JavaScript where if your key and your key matches the name on the object, you don't have to do this business. So maybe we can just refactor that to just name. So we don't have to do that, and do the same thing here. Maybe just make this type, and we can delete it. Cool. So that should be pulling out all of the
animation tags from Aseprite. Let's maybe go and set, because we only have like one animation. I wonder if we should set another animation here in Aseprite. So let me switch over to Aseprite here real quick and see if I can remember how to make an animation. So new tag. We'll call this animation 2, and then we'll make it reverse. Sure. Okay, so now we have a second animation here. So let me save this in Aseprite, and let's go back to the browser and see if we can load that up. See if that's working. And lost my breakpoint. Here we go. Number of tags. Here we are. All right, so now we should have 2 tags, which we do. That's good. And we're going to read the from. So this is the first one, the from and the to. The type is ping pong. Repeat is 0. And then we have some byte padding, and then we have a name, which is our loop, which is our first one. So we're going to set that first tag. So we got our loop with all of our stuff, and then our next one should be from 1 to 2, because we're 0 indexed. We're going to get type 1, which was, what was that? Type 1 was reverse, which is what we set. Cool. And repeat is 0, and then we got some random byte padding, and then we have animation 2. Awesome. We are parsing this native binary file. Very cool. All right, so now we have all the tags out of here. Now I want to see if things still work. Okay, cool. We still got a wrong animation playing, but it's looking good. All right, so bouncing back here. Now we want to create an animation out of what we've got. So let's see. We've done all of this, and in our resource, we are wanting to grab an animation by name. So we want to be able to get at that specific animation that, like, we want to be able to get at loop, or we want to get at animation 2. So what I want to be able to do is I want to be able to say, hey, parser, get animation name is what I want to be able to do. And then it'll build up an animation for me. That's what I want. Okay, so let's do that real quick. So I have get frames here, which gets us all the frames, but now I want get animation name string, and that'll return me an animation, an Excalibur animation, theoretically. Animation from Excalibur. Did it not update the import? Okay. Oh, no, it's just I am not returning one. Cool. So then we need to go and say, okay, this dot tags get name. So we've got our animation tag for this, and if we don't have one, we need to throw, because there's no animation by that name. We can do some string interpolation here. So there's no animation by name. Cool, so there's no animation by name, that name. Otherwise, if we did find it, then we can grab the specific frames. Basically, we can just go from to, and we can slice off of this, right? Returns a copy of a section array. We have a start and end. Okay, so we can do that. So we can do animation tag from and then end index animation tag 2. So we theoretically can just do that. So we got our frames for this guy, and then we need to build up an animation. So we'll build an animation here. We can give it its frames. And then we need duration. How does the duration in the spec work here? So we don't have it in the tags. It's just a part of the frame, wasn't it? In this, was it in here in the Cel Chunk? Let's see, duration. Oh, it's just in the header. Oh no, you should use the frame duration field. Okay, so there's a frame duration. Okay, so when we parse each frame has its own specific duration. So we need to store that information when we're parsing. So let's grab that real quick. I am a fan of maps, so we're going to use a map here. So I'm going to store based on the frame number, we're just going to store the duration in milliseconds. I was a Pascal programmer in my past life, I bet, because of all the maps that I like. All right. I'm going to go frame number to duration. Okay, so then when we're parsing a frame, we have duration in here somewhere, theoretically, right? We've got parse frame, parse chunk. Okay, where was the duration? Bytes in the frame, it's frame size. Looking at the spec here, we have the bytes in the frame, we have a magic number, old chunks, and we have a word that is the frame duration. Am I not reading that? Oh, I am reading that. I just can't see. Okay, there's the frame duration. So, cool. Which frame am I? Do I know which frame I am in here? I probably need to pass down what frame I am, because I don't know in this block which frame I am. So I probably should okay, yeah, I probably should parse or push down like what frame. So in parse frame, I'm going to pass down frame number. This is really messy, but we're just going to roll with it. So I have the frame number now, and then when I have my frame duration, I'm going to go ahead and just go ahead and make that happen. Frame number, and then we have frame duration. Cool. All right, so then in our animation, we know our duration. And this is a duration for if you wanted to make every frame be the same duration. But in Aseprite, you can set specific durations per frame. So I actually want to map these frames and produce their durations. When I'm doing this, how am I building EX frames? Because I probably could just do it there. So parse frame. Actually, EX frame already has its duration from the frame duration. So I didn't need to do that. Oops. All right. So that's fine. I didn't need to do that. That's what I did that 3 days ago. Of course I can't remember that. All right. So we already have our duration in there, so that's fine. So frames already has its duration. What else do I need? I need strategy. So we have animation strategy. So this is where we need to figure out from the type in the tag whether or not we're doing ping pong or not. So if, so let's do if type oh, I did this wrong. Should be the other way around. All right, so let's flip this around. Oh no, multi-line is failing me. All right, let's do it the hard way. All right, so if we have our type, I'm just gonna make these be like this. There we go. That way it flows nicer. There we go. That way, if my type is forward, I need, if my type is forward or my type is, yeah, if my type is forward, I'm going to need to set my strategy to be animation strategy. I think forward is just, I can't, ends the animation in Excalibur and it doesn't display the last frame. Freeze stops right on the last frame. I think end is correct. So if it's type forward or type ping pong, no, if it's type forward, the strategy is end, I think. Probably, I could be wrong. Else if the type is reverse, or ping pong, excuse me, then the strategy is ping pong. Yes, and then if, yeah, so that's our strategy. That's all we need for strategies. And then if we have a reverse in any of those, so we'll say reverse is false by default if type is animation types reverse or animation types type, ooh, can't type, animation types ping pong reverse is true. And I just realized I missed the ping pong reverse up here. So we just need to do an or on type ping pong reverse. Okay, so I think that grabs the reverse. And I don't know if we have a repeat. So we don't have a repeat thing, I don't think, in Excalibur. We don't have like a repeat n times. So I think we're just going to leave that one alone. Yeah, I think we're going to just leave that one alone because I don't think that we have that. I'm almost positive that we don't. Yeah, we don't have that. Maybe a new feature? I don't know if we should. I don't know if that's important or not. Repeat a specific amount of times. It could perhaps be important. Okay, cool. And then we can return that animation. Very cool. So, in theory, I don't need to do this anymore. Let's get rid of this. So in theory, I can get my animation by name, which is super dope. We'll get rid of this. We don't need that anymore. And then I don't need the thing I made up here anymore. Cool. So in theory, now I can get an animation by name and return it. So it doesn't like this because it could be undefined. So we're going to just say that it is definitely defined and say, take that TypeScript. Okay, let's see if that works when we call it in main here. So we should be getting a loop. And do I need this as any anymore? I shouldn't. Why is that complaining? Could be null. Oh. Animation from Excalibur. Cool. We're very confident that it won't be null. All right, let's see if that's working. Let's go over to the browser and hit play. Ooh. It looks like it might be only 2 frames. It doesn't look like the 3 frames that loop is. So I wonder if we got an off by 1 issue. So let me switch over to, let me switch over to Aseprite real quick just to show you. So we got, in loop, we've got 3 frames. I'm pretty sure that's what's playing here. Can I play a specific animation? Yeah. So let's switch back here. And see why we are getting stuck on only having 2 frames. Get animation. So let's set a breakpoint here and see where we are. Okay, so we're gonna get the tag, which we have. So frames, we have our 3 frames, and we're gonna do a slice from 0 to 2. Is that just not including the last one? Okay. That's probably my fault. It's probably not inclusive, that last one, in JavaScript. Let's go look at the Endian docs for slice real quick, and we'll convince ourselves that that's okay. End not included. Okay, so end is not included. That's why. So we need to go ahead and fix that. Let's go switch over here. Get animation. And our slice, we'll just give it a +1 to include the end. Cool. So then over here in the browser, we should see all 3 frames there. So let's go and make sure that we're seeing what we think we should see. Enhance. That looks like it's ping pong. Does it look like Aseprite? Yeah, so there's that animation, and if I go take a look at Aseprite now, yeah, it looks like it's ping-ponging. Nice. Okay. I'm feeling pretty good about this. So I think we're reading the tag information right, and let's see, what else do we have to do? So we're reading our tags, we're extracting animation. Now we want to check to make sure that we can support multiple layers. So let's do that. So I'm going to go over here to Aseprite and add some layers. Let's go to Aseprite here and do some on-the-fly editing here. Let's see. Let's add a layer. New layer. I'm zooming in all over the place here. All right. I want to zoom in over here. How do I get the picker? Here we go. I want to zoom in. There we are.
All right, so I'm gonna move layer down. Oh, I didn't want to do that. Can I drag a layer? Ooh, I'm really struggling. There we go. So let's just draw something here that would be very obvious. Can I not? Oh, weird. Oh, okay. It was I just don't know how layers work. Okay, so let's just draw some random stuff on the layers that looks kind of gross. There we go. We've graffitied our beetle. Okay, so let me save that. And let's go back here and see if this just works out of the box. And you know, if it works out of the box, then I'll be very pleased. Nope. Okay, so that's what I predicted. So we're only reading the first layer that we see in the file. Okay, so now we need to support multiple layers. All right, so let's go read the spec here and figure out how layers are supposed to work. Okay, the first frame. In the first frame should be a set of layer chunks to determine a layer's layout. So there's a lot of fancy pants stuff in here. We've got blend modes on layers, layer heights that are ignored, tile set index, layer name. I don't think we need that for including. So what I want to do is I want to flatten all of the layers when I'm producing an animation. Is what I want to do. And I think we can do that. So when reading the Cel Chunk, we're getting the layer index. We'll see note 2. What is the layer index? The layer index is a number to identify the layer in the sprite. Layers are numbered in the same order as layer chunks and appear in the file. Well, for lucky, that means that in your file you'll find the background layer chunk first, then layer 1. Oh, so then we can probably just do like a painter type algorithm here to support the different layers in Aseprite. So, okay. I kind of expected that to work then. So why is it not? So when we parse the frame, we are drawing the first layer to a canvas. So when we're going through all of our frames, we create a canvas for each frame, and then we parse the frame. How come when we're loading up each chunk, we are not just painting over it when we parse the frame? So here's, let's see, let's go to Parse Chunk. Let's look at, let's clean this up a little bit. So this is what we do right now, is we get image data and we create a bitmap and we're drawing images into the context. Oh, you know what? I bet setting the context width and height invalidates the context. So I wonder if we need to do that up when we create it. Let's try that one more time. So one thing that is problematic about setting like canvas, like changing the canvas size on HTML5 canvas, is that if you do it, it invalidates the context and you need to redo all of the properties that you've set on it. So I'm wondering if that's what's going on. So let's try that, because I expected this, because we're not like clearing the context every time. It's the same context when we're parsing all of the cells.
So it should be the case that we're doing like the painter algorithm where we're painting down each layer with the draw image, and each layer should have like transparent pixels. So this should just work to like draw each layer on top of the context, the frame context. Let's see if that works. Let's hop over to the browser. Hey, that's it. Okay, so that was it. So setting the context height was the deal there. That invalidates the context. So huzzah, we just have to set the height at like the top. Well, that worked way better than expected. What are we missing? Let's see. Let's go look at our to-dos here. Well, let's look at our to-dos not in a diff. So we're supporting multiple layers. That was way easier than expected. We have some refactoring to do. We can do. What else can we do? The other thing I noticed is we don't support the whole API yet, like getting a sprite sheet. So we figured out getAnimation. We don't have the sprite sheet support yet, and we don't have this raw Aseprite. I don't know. We might. This is going to be a breaking change, I think, because this raw Aseprite doesn't really make sense in the native file format, because this is the shape of the JSON. So I might actually rename this to be more clear about what it is. And then break my tests immediately. Let's see. I'm gonna have to restart my tests. Let's rerun this. Theoretically, it's working now. Okay. So we want to make this API the same, roughly speaking. So this should be building. Okay, so it built. It was just stuck when I did the refactoring. Oh, maybe I should rename this type, this file as well. Yes. Let's update those imports. Cool. All right, let's close this guy. We don't need him anymore. So let's see. We've got load. We're parsing. We don't need this anymore. And then, okay. We're missing two parts of the API, the getSpriteSheet and the data that makes sense here as a sprite sheet. So does this even make sense anymore? Maybe it does as a container for this sprite sheet and animations. Yeah, I think it does. So after we're done parsing, we want to produce one of these, I think. And then build up our sprite sheet, which is the thing we're missing. So let's do that. Let's build up an actual Excalibur sprite sheet in the native parser. So let's do public get sprite sheet. And what does a sprite sheet need, pray tell? I think it just needs images, which we've got. So our sprite sheet options, let's see what they've got. Yeah, we just need a list of sprites. So this should be easy, because then this is just our frames. map frame. Oh, maybe I can't do that. Do I have the raw canvases? I have canvas frames. How I have my normal frames here. How am I doing this? Because I have my image source that we're building this up to. Where do I set those EX frames? Where are they set? It's a mystery. I must do it somewhere. Oh, here we go. Okay, this is where we do image source to sprite. So these are sprites. I kind of want to store the sprite. I kind of want to do this differently. Yeah, I'm going to store the sprites. We'll just do it. We'll store them at the same time. So we'll convert these to a sprite. We kind of have this hack right here. We probably won't fix this today, but we should update Excalibur so that we can make an image source from a canvas, because that's what we would like to do right here. But we're doing this like roundabout way of converting it into a URL so that we can load it, which kind of is gross, but it works. Sprites, push sprite, and then we'll just put the sprite in here too. Okay. So then all we need here is just the sprites. That's it. So that should do it. So we've got that API tagged down. Now we need to actually produce one of these sprite sheet thingies. And I think we can just return one of these. Okay, so we can do AsepriteSpriteSheet new one of these, extra new, double new. We'll get one of these, and then we'll we want to set the animations and the sprite sheet. Okay, so what are we doing here for the old one? Basically, this is a wrapper around. This is basically the JSON parser. This is a wrapper around the JSON parser. So this is like, if we were to refactor this, I would actually maybe like, here's what I think I'm going to do, is instead of doing this, is I might kick this into a separate file, because this basically, all this is doing the JSON parsing and producing the types. So let's do that. Let's call it Aseprite JSON parser. And let's move this logic into there. So let's see. We want export class Aseprite JSON parser. And this, you give it a raw and an image source. And then we're going to have the same API here where we call parse. And it's not async in this one. So then this guy, does a lot of stuff. Let's get all of this imported here. This needs to be animation and spreadsheet. Cool. So that looks pretty good. And what I want to do instead here is, instead of creating this sprite sheet and returning it, I want to return, I basically just want the same getters that we added. So I'm going to get rid of this. And what I'm going to do instead here is set some private members here for this. So is that what we're doing in here? Basically, that's what we're doing in here. Yeah. We're basically just doing that. So this is just going to be a container for those. Which makes sense to me. This, and this parse isn't going to return anything. Neat. Okay, so I'm feeling pretty good about this. Let's undo this. Okay, so then in our resource, what we'll wind up doing here is we've got our raw Aseprite and image, which don't make sense anymore. So this is going to be a breaking change. So I'm going to not expose those. And then instead, we're going to do a JSON parser here. So we have a native parser that we defined up here. So we're going to do private JSON parser. Sprite. Did I not export? Okay, I did. It's just not picking it up. So we've got a JSON parser and a native parser. We've got a native resource and a JSON resource. And I'm just going to align these so they're close to each other. It's probably a better way to do this, but this makes sense to me right now. Okay, so and then in here, what we'll wind up doing is we'll create our JSON parser, Aseprite JSON parser, and then we'll give it the Aseprite data and SpriteSheet image, and then we'll parse it. Parse, and then all we need to do is return this SpriteSheet container that will contain the animations and SpriteSheet. Cool. So then this JSON. Let's update. Actually, we need to update that container before we can return it. AsepriteSpriteSheet. So this gets really simple. Yeah, this gets super simple because this is just going to be SpriteSheet and animations. Which is a map of string to animation. And those are, yeah, and then we need to set them because we have some validation logic in here, which is fine. Okay, so that's all we need to do, and then we can delete this whole thing since we moved it into the parser. And this clone gets a lot better. Get rid of this. And then we go over here and we fix this so that we return getSpriteSheet, JSON parser, getAnimations. Sweet. And this needs a new. Awesome. That is looking real slick now. And then we just got to fix this one down here. And then I think we're done. Maybe. We're going to put it through its paces here and see if we got any extra stuff that we need to do. Native parser. Get SpriteSheet. Native parser. Get animations. Okay, so I need to fix that up. And I think we do have, in the native parser, we do have animations just hanging out. Or we don't. We just have get animation. Well, we can make that. Get animations. And then we'll have this return a map of string to animation. Which will be easy because we have all the tags. So we can just loop over all of the tags and get an animation. So result, new map string, animation. let tag of this dot tags dot keys. Yes. So we'll go through all of the keys and we'll produce an animation from that tag. And then we're set, in theory. In theory, that works. If there's no array buffer, I'm just going to throw. That way I don't think I need to do these bangs here. Yeah, TypeScript is that smart. That's cool. And then we have path. Yeah. Cool. Neat. All right, so we don't need these anymore. That's a breaking change. Do we have everything fixed? We're going to have to fix some unit tests. So this just needs to be different. So this is effectively the parser now. So this is testing the parser, which we probably should move to a new test. So we will make a new AsepriteJSON parser, which I would like it to be from here. Oh, it's not being exported at the root. Let's do that real quick. Do both of those. Grab that. Grab that. So then this just needs to be basically the what are we returning out of here? Basically, we just need to make a ace. You know what would be nice is if we just could kick out one of those types so that I can make the test work. Get AsepriteSheet, and then we can do. So instead of doing it here, we can just get it out of the parser. Oop. So we can do the same thing here. I'm digging this. This feels pretty good. Cool. And then in here, we can do the same thing. Cool, and then we can do that same thing. Then our tests are the same, and we don't have to worry about fixing them. Oh, can you hear my cat? She's upset that the door is closed. Okay, cool. So in theory, that fixes the tests. Let's restart the tests here. This test build. Make sure that that still builds, and then I think we might be able to declare victory. That still works. I might work on the unit test later, but I think this is pretty good. Oh, we still have some issues in the spec. Oh, in this one. Oh, well, we don't do that anymore. And then we don't do these anymore. Did we get it? Yeah, Webpack just gets sad. All right. See if Webpack is okay now. Think so? Huzzah, everything still works after that refactoring. So that's always good. Awesome. So I think that is feeling pretty good. Let's see if there's anything in the to-dos here that we want to do after the refactorings here. So I think we kicked through all of the things that I wanted to do. I think it's just going to work. I think the only thing that is probably left is anything like fiddly that I missed or any bugs. So this will be really cool in the next release. We'll be able to show this off, you know. And then if you were, you know, what kind of spurred this on was that there's a importer from Unity that is that you pay money for. So we figured it out without having to pay money for it. So I think, yeah, there's a fix me in here that we could fix because this is going to be problematic. I can fix that later. Yeah, I'm feeling really good. This actually turned out super good. Yeah, there's a bunch of stuff that we don't need to parse. I think that, you know, the only thing that we could maybe do in another stream is indexed color types. So like in Aseprite, you can, in addition to like doing stuff with, let's see if I can find it. RGB, you can do indexed or grayscale. We probably should figure out how to do indexed. Shouldn't be too bad, but I think what I'm going to do is I'm going to call it there. I think this is pretty close to being completely done. So I'm going to call it there and check this in. And if you want to check out the branch for this, let me pull it up and you can check out the code. Let me just commit all of this code here. We're going to call it fix all of the things. We're just going to check it all in. And the unit, you know, stuff might break, but locally it seems to be working. So that's always good. We'll probably have to spend some time offline doing the unit tests here. And let's go to the repo here, one of them, and find the branch. Native Aseprite, there it is. So if you would like to check out the code for yourself, or take a look at it, or spot any bugs, let me know. That's the branch, but I think we're gonna call it there for tonight. Yeah, this was good. I'm feeling pretty pleased about this. We're gonna make this part of the next release for sure, and make sure it's solid. But yeah, I think I'm done. But this is great. Thank you everyone for sticking with it. We'll see you soon. Bye bye.